So today's learning target will be able to factor a trinomial into two binomials. So basically we're going to be undoing the process of multiplying binomials and trying to put it back into that double binomial form. But let's first talk about something that we've already done, multiplying binomials, to show you how we get there. So if we have x minus 2 in parentheses, that's a binomial, and then x plus 7 in parentheses, that's another binomial, we can multiply this with the box method, with distributing, and so I'm going to go with what most students have been comfortable with, and that is the distributing method. So we take the first binomial and we break it up into two parts. So we break up this into an x times the second binomial, x plus 7. And then we take the negative 2 and we multiply that by the x plus 7. Okay, so we've got it broken up into its two parts, and then we try to distribute. So we pass the x out to both terms. Remember that x times x is x squared, x times 7 is 7x, and then we do negative 2 times x, negative 2x, and negative 2 times positive 7, a negative 14. So we end up with 4 terms. We try to find like terms. They usually sit right here in the middle, and so add or subtract those. Based on signs, we are going to subtract these, and we'll get x squared plus 5x minus 14. Now, I went through that kind of fast because that's something we've already done. We've already learned how to multiply binomials. But today, it's going to be about factoring. Now, when I say the word factoring, we've talked about this before. We've factored by GCF. Last time we factored the difference of perfect squares. We called that dots. Today, we factor trinomials, meaning we go from 1, 2, 3 pieces and put it back into its binomial form. And we've got a process for how we do that. And let's think about how we got there. We got to the positive 5. We got to this middle term by adding these ones, right? Now I know that we subtracted, but we really added a negative. And then we got to the 14 by multiplying. So think about adding to get to this middle term, but multiplying to get to this last term. And if you can think about that, we're going to do very, very well today with what we've got. All right? Again, any questions, go ahead, type them in the chats, and please feel free to use your microphone this morning. So let's get to the first one. We have a trinomial. We have x squared plus 7x plus 10. 3 unlike terms that we cannot add. So we want to try to write these as an equivalent binomial, meaning two binomials. So 1, 2. Sometimes setting these up makes this a lot easier. Now the x squared, we always get that from multiplying x times x. So when this is just a 1, all right, it makes it a lot easier, and we could just split this up into 1x in the first binomial and another x in the second. Now how do we come up with those numbers? Well, remember we said we added to this number and we multiplied for this number? Well, what we want to do is make a factor list. We want to write the factors of 10. And so that's as simple as just doing 1 times 10, 2 times 5, 3 times no other whole number gives you 10, nor does 4, but 5 times 2. But we know that multiplying 2 times 5 and 5 times 2 is pretty much the same thing because of the commutative property, so we stop. We stop writing factors when we repeat ourselves. So there's only 2 pairs, and what we're really doing is just writing ways to multiply to 10. Factoring, fancy way of saying, how can I write ways to multiply to 10? Well, that's going to help us get the last term, the 10. But remember, I add to the middle term. So I set up a little x here, and you don't have to use this all the time, but there's a number we add to, and there's a number we multiply to. And we add to that middle piece, the one that has the x, and we multiply to the last number, 10. Now, what pair of numbers that I've listed here is going to do both of those things? Only the 2 and the 5. Only 2 and 5 will both add to 7. So 2 plus 5 makes 7. And then 2 times 5 will make 10. They make both a positive 7 and a positive 10 when both of these are positive. So we take our 2 and our 5, we put it inside the parentheses, and there you go. The two binomials that would multiply and make that trinomial are x plus 5 and x plus 2. I'll give you the chance to kind of get that down. The setup for this is 2 sets of parentheses. Because this is just 1x squared, I can quickly write this as x and x. Remember that we're trying to add to this number, but multiply to this number. I'm going to use the symbols to kind of help us out. I'm going to make a large X because there's one number I'm adding to. That's the 7. That's the number in the middle. And there's one number that I'm multiplying to, and that is the 6. And you do want to try to think about including the sign in front. I'm going to make a quick factor list of 6. So again, I just suggest starting with 1 and multiplying it times itself, 6, to get things going. Then try 2. Does 2 go into 6? Yes. 3 times, 2 times 3. And then 3 would be times 2. But 2 times 3 and 3 times 2 are pretty much kind of the same thing. So there we go. We've got our entire list, just those 2 possibilities. Now, it's got to do both things. It's got to add to 7 and multiply to 6. If we do 2 plus 3, this only gives us 5. So that's not going to be enough. So it's going to have to be the 1 and the 6, because 1 plus 6 makes 7, but 1 times 6 makes 6. So plus 1 plus 6, and there you go. You've just written it as 2 binomials. Changing the letter doesn't change the process, so just understand that instead of x, we're just going to write 2 binomials, and the first term is going to be b and b. Again, there's a 1 there. It makes this process so much easier. I'm going to keep using the x, okay, so that we're consistent here. There's a number that we add to. There's a number that we multiply to, okay? Hear me repeat myself. We're going to add to the -9 and multiply to the 8. So the 8 is the number I write the factor list for. Always start with 1 and 8 because you never know when that's going to come up. And then go 2 times 4, 3 times nothing whole, so don't use 3, and then 4 times 2. But as soon as you see a repeat, even though they're in a different order, you don't need to go any further, okay? So from there, pick the one pair that actually does both things. Adds to 9, multiplies to 8. Well, 2 and 4 are only going to give you 6, so that won't get to 9, so it's 1 and 8. Now be careful with signs. It needs to add to a negative, but multiply to a positive. So the only way that happens is if both are negative, right? -1 plus -8, -9, -1 times -8, +8. A negative times a negative makes a positive, but when you add two negatives, it stays negative. And so your integer rules, super important as you go through this process. And hopefully, as for the next one, it's a trinomial with a 1 in front of the b squared. So that means I can easily get this to 2 binomials. I'm going to go b here and b there. Now, I want to add to the middle term, multiply to the last number that has no variable. I think about this as a little x where I add to the -9 but multiply to the 20. I'm going to have to make a list of ways to multiply to 20 and just go right in order, okay? 1 times 20, 2 times 10, 3, no, 4 times 5, 5 times 4. And if you're not that good with your multiplication facts, use a calculator, right? Just start with 1 and then just keep dividing by that number, and hopefully you can see the list that is created. So this time I've got 3 possibilities, but only one will do both things. So how can I add to -9 but then also multiply to 20? Well, 1 and 20, sorry, you're not going to cut it. 2 and 10, you're close, but not quite. I can add them for 12. I can subtract them for 8. So no. But 4 and 5, that's going to be our money here. Now, how can I again add to a negative but multiply to a positive? If both numbers are negative, a negative times a negative is positive 20, and a negative plus a negative stays negative 9. You owe 4, you owe 5, you owe $9. So there you have it. Take those two numbers, put them in your parentheses. Don't forget to have a trinomial with a 1 here. And I keep doing this. You're like, why do you keep doing that? Because later on it's going to be different when we're not going to have that. So we're going to have to kind of prepare for that. This time it's y squared, meaning there's two y's. So let's break it up. Let's put 1y there, 1y there. We don't have to write the exponent, but again, 1y, 1y. Now, we want to add to this number here, but we want to multiply to this number. So we want to think about ways to multiply to a negative 18. 1 times 18, 2 times 9, 3 times 6, 4, no, 5, no, 6 times 3. Again, I'm just making a list of ways to multiply to 18. But that is a negative 18. And what do we know about multiplying two numbers to get a negative? Well, we just saw that if they were both negative, it made a positive. And if we multiply two positives, we got a positive. So if we're going to get a negative 18, these signs have to be different, okay? So different signs, and it also has to add to a 3. So add to 3, multiply to negative 18. Well, what's going to do that? Certainly not 1 and 18. Can't get 3 out of that. 2 and 9, can't get 3 out of that. But 3 and 6 would be the two numbers we're looking at. Now, signs are important because I add and it's positive, I multiply and it's negative. So I know they're different, but the bigger number is going to have to be positive, right? Because if I'm going to get positive 3, the bigger number is positive, the smaller number is negative. Because negative 3 plus 6 is going to be positive 3, but negative 3 times 6 is negative 18. So put this down as minus 3 and plus 6. The first time you have seen different signs. So again, we're going from a trinomial into two binomials, because that's what happens when you multiply two binomials. You get a trinomial. We're going to split up the y into y squared into y and y. Then we're going to make a factor list of negative 10. Don't make this harder than it is. Just think of ways to multiply to 10, like 1 times 10, or 2 times 5, 3 times 4 times and 5 times 2. And I apologize, the are coming from Mrs. Petrie wanted to watch the Mars movie, when they Invasion from Mars by Tim Burton back in the 90s. Terrible movie, but these little aliens make this annoying sound and I can't seem to get it out of my head. Anyways, remember we are adding to the middle number, multiplying to this number, so let's make our x. Now if you feel like you can do this without the x isn't a verified process that is required. It's just a process to kind of help you organize your work. So how can we get to 3 when we add but 10 when we multiply? We're good with the multiplying, but think about the adding. If I add 1 and 10, I could get 11. If I subtract them, I could get 9. So, not going to work. But the 2 and the 5, yes, that's going to get what we want. But we got to think about the signs. When I add this, I get a negative 3. The only way that happens is if the bigger number takes that sign. So the bigger number is negative, smaller number 2 is positive. So we think about 2 plus negative 5 being negative 3, 2 times negative 5, there we go with negative 10. So we slide it in here as plus 2 and minus 5. The two binomials that would multiply to that there trinomial. Okay?